The project topic is Motion Sensor Navigator, that's it, the MSN system.
I am Max Cheng.
I'm Alex Chen, students from Department of Electronic Engineering, City University of Hong Kong.
Last year, we have entered HKICT Awards Best Student Invention 2014 with mobile device and cloud server-based intelligent health monitoring system. We have won the Merit Prize and now we are having our patent in the US. And this is the photo from the award ceremony of last year. So now we take our retrospection on what we have done in 2014. In all, we have created a device that can record motion data of people attached to it, analyzes the motion data by computer or mobile phone, gives sleep statistics, gives insights of physical activities, and as elderly healthcare alarm.
So, what's left in our quiver? With the framework complete, we can consider new possibilities. Also, we can turn the product to full implementation. Let's talk about what we have done in these few months in order to make our product more fully implemented. First, we have built a Wi-Fi based falling alarm for elderly. For detecting the falling action, this falling alarm uses two different types of sensors, which are the accelerometer and the gyroscope. Let's have a quick look at these two sensors. Accelerometer. Accelerometer can be used to measure an object's acceleration. When a person is falling, there will be a sharp change in the acceleration. By recognizing the change pattern, we can detect whether a person is falling or not. More than that, by having enough amount of data sampling, we can even use the pattern to distinguish the falling action from other all kinds of similar action. For example, crouching down. Apart from the accelerometer, there is also a gyroscope used to help us for detecting the falling. A gyroscope can give us the angular velocity of an object. By having some calculation, we can turn this data into what we desire, the object orientation. Similar to that in the accelerometer, when a person is falling, there will be a change in an object orientation, and using this piece of information, we can distinguish the falling action from the others more accurately. Based on the two sensors, our machine can now detect and distinguish the falling action. And as I have mentioned, our machine is a Wi-Fi based application, therefore it is suitable for a many-to-one situation. For example, it can be used in an aged home. When an elderly who has worn our device has fallen, the device will trigger an alert signal to the server through Wi-Fi, which means it will alert the staff in the aged home to perform an on-time rescue to the elderly. So, we have just talked about the Wi-Fi based falling alarm for the elderly, which is actually a many-to-one application. How about a one-to-one application that is suitable for all of us? This is in fact what we are doing currently. Instead of using Wi-Fi as the communication method, Bluetooth is being implemented. However, unlike the project in last year, Bluetooth 4.0 is used but not the Bluetooth 2.0. Let's talk about what is the difference between them. Why we would like to use Bluetooth 4.0 instead of the original Bluetooth 2.0? Bluetooth 4.0, also named as Bluetooth Low Energy and Bluetooth Smart, is a very new technology. Actually, it is designed for applications like healthcare, fitness, security, home entertainment industry, and etc. One very important feature of Bluetooth 4.0 is about its super low energy consumption property. When compared to Bluetooth 2.0, Bluetooth 4.0 only consumes less than a half of the power. Therefore, as the power consumption has decreased, the operating time of the device can be longer. And this is the main reason of why we would like to change the Bluetooth 2.0 to Bluetooth 4.0. With the low power Bluetooth 4.0, a one-to-one fall detection application for personal health caring can be implemented. Unlike the situation in the Wi-Fi based falling alarm, where the terminal is a PC server, the terminal of the Bluetooth version would be the smartphone. When a person is falling, our machine will send an alert signal to the phone. If the situation is really serious, the phone can even call the ambulance for help. That's all about the work we have done in these few months and the work we are now in progress. Let's talk about some other features that can use our MSN system.
So now let's talk about the spin-off functions. For babysitter, if baby is sleeping with face down, they could easily suffocate. By using gyroscope, baby's current orientation could be known. If the baby is sleeping face down, the device can notify parents by sending an alarm or a message. Then they can proceed to help their child. Parents can also acquire baby's location and navigate several camera feeds at home to monitor the baby by mobile app. And finally, assess baby's current motion like sleeping. For pet caretakers, pet owners can assess pet's location and their current movement, just like the similar approach as the babysitter function.
In summary, by using the MSN system, a Wi-Fi-based falling alarm is nearly fully implemented. At the same time, a Bluetooth-based falling alarm is still in progress, while the MSN babysitter and the MSN pet caretaker are going to be developed. As we have said, the Wi-Fi-based falling alarm can accurately detect and distinguish the falling action. So, how accurate can it be? We can have a rough image by watching the following demonstration. In order to use the system, user has to turn on the device and wait until it has automatically connected to the PC server. Then, wear it at the position near the waist. After that, open the web page that shows the result of the falling alarm. And in this stage, everything is ready. Let's have a look at some normal situations. Normal falling. Slowly falling. How about some other kinds of actions that look like falling but they are actually not? Crouching down. Jumping. Sitting down. Throwing the device into air. Dropping the device from a desk. From the previous demonstration, we can find that Wi-Fi based falling alarm can clearly detect and distinguish the falling action.